So in this example here, we picked a test limit that was in the tester, but often or not, when you're doing fiber optic cabling, you may be operating to a custom loss limit. So Amanda, I'm going to show you how to do that. Go ahead and tap New Test for me, because I can create 10 test setups per project. I can have a setup that's multi-mode and a setup that's single mode. I can have my fiber inspection. I could even throw some copper testing in there as well. So where you see test limit, tap test limit for me and tap more, and you'll see the option that says custom. So go ahead and tap custom for me. And so looking at the custom, we'll tap manage because we want to create a new one. And we got 3 options on here. Let's create a new one. Excellent. And we have our option on here to put our name of our custom test limit, but what I want to show you here, this is where you're going to put your loss values in. So when you're creating a custom test limit, there's 2 flavors to choose from. There's fixed and there's length-based. Length-based is where you want to take something like the TIA or the ISO standard and tighten up the fiber loss requirements or the cable connector requirements. You may have a situation where the consultant has already specified what the loss of that link is and it's just a fixed loss value, in which case you would tap the fixed loss. So go ahead and tap fixed loss. And then you can see the screen here automatically changes and then you just put your values in. But we're not going to do that today, we're going to leave it just as it is. Okay, so now we set up the CertiFiber Pro, we're going to set a reference and we're going to do this 1 jumper reference. And this has to be probably one of the single largest cause of support in fiber testing, not just at Fluke Networks, but right across the industry. Even after 7-8 years of talking about this method, I still find myself teaching it to people that have never ever done it this way. So, the great thing about this product is it's going to walk you through the process. Because we set it as 1 jumper, the screen's going to walk me through. So Amanda, go ahead and tap set reference for me. And we're going to run the wizard. So go ahead and tap the run the wizard. And the first thing it's going to do is it's going to tell me, and you see on the animation, I need to connect my cords to the output ports. On the drawing here on the screen, you'll see the little puck, which is this thing here. Now when you look at this cord here, we've got a 50-50 chance of getting this the right way around, and it does actually matter. You'll notice on our cords that one end is red, the other is black. The way that I like to remember this is red is hot, black is cold. So the red is connected to the output port on the instrument here, but you can also see that on the LCD here where the red is connected to the output port. So I'm going to gently connect my cords to the output port here. And this is a quad, which means it's both multi-mode and single mode. So this is my multi-mode port, and this is my single mode port, and this is my input port. Now you'll notice here that the fiber inspection camera is attached to my instrument. So off camera, before we started this, I went through and I inspected all of my test reference cords. That's very important to do because even though they're brand new out of the bag, that's no guarantee that they're clean. In fact, we did find a couple of them were a little bit dirty on the end faces, and we cleaned them, and more importantly, we inspected them again. You can clean them using these one-click pens, but the false assumption there is that once I clean it, it's cleaned. You don't know it's clean until you've inspected it. So without a camera, you're going to have a pretty rough time doing your fiber optic measurements. So, our cords are connected to our outputs at both ends. The other thing I forgot to mention, of course, is that these instruments are switched on and they'd be left on for at least 5 minutes to stabilize. If you don't allow the sources to stabilize, you're going to end up with negative loss results. Okay, Amanda, go ahead and tip next. So the next thing it's telling me to do is I want to connect the 2 instruments together. So I'm going to hand my LC connection to you. We'll do a swap at this end and we'll place them onto the input ports. This is LC out of the box with the CertiFiber Pro. If you have a need to do SC testing or ST or FC, you can buy your hybrid kits to do that. And in addition, you would change out the inputs. So the inputs here are LC, this one is an ST, and that would allow you to do ST testing. Likewise, you can get one of these for SC and FC as well. You may have heard on the audio that when we connected them together, you got that bleep. That confirms that we got continuity, that we got the polarity correct between our main and our remote unit. You can also see that in the top left-hand corner of the screen here. next to the battery icon, you now see two little tester icons with green arrows pointing left and right. That tells us the main is now talking to the remote unit. Okay, Amanda, go ahead and tap set reference for me. This takes about 3 seconds to do, which is a lot quicker than it was on the DTX, which is about 12 seconds. So our reference is set. We've zeroed out these codes here. Go ahead and tap next for me. Okay, it wants us to disconnect from the input ports. Let's go ahead and disconnect from the input ports. We never ever disconnect from the output ports. The moment you disconnect from the output port, that invalidates the reference. Let's do a swap. You have that one. I'll have this one. We'll just lay them down here on the table here. Okay, what's next? Go ahead and tap next for me. What's it asking us to do now? It looks like it's asking us to take our other cords and place them in the input ports. Now again, we've got a 50-50 chance of doing this right. One end is red, one end is black. Since it's the input port and that's the code, we'll put the black into the input port. Also noting on the screen here, it's also color coded on the screen. So let's take our black connector, plug it into the input port. So when we look at the main unit now, we'll see that we have a presentation which is duplex. And likewise, with Amanda's remote unit, we also have a duplex presentation here. So we could, in theory, just go off and start testing, but that would be a bad idea because we don't know how good our test reference cords are. So Amanda, go ahead and tap next on the screen for me. And it's asking us to join the two cores together. So I'm going to do that with these single mode rated couplers. Now I like to use single mode rated couplers even though we're doing multi-mode testing because these have much better performance. Their dimensions and their tolerances are much better than multi-mode couplers typically. So I'm going to plug this one into here. And it's black to red, red to black. Again, that's indicated on the screen here. And we'll do the same here. And if all goes to plan, we'll hear a bleep. I got it right, got the polarity correct. We got our continuity between the two instruments. Okay, let's do our test reference chord verification. Go ahead and tap TRC verification. This takes about 3 seconds to do, certainly a lot quicker than that DTX. And we have here now our TRC verifications, and we got a couple dB loss values on there. What are they, Amanda?
They are 0.05 and 0.13.
Nice, that's fantastic. The international standards say for multi-mode that it needs to be better than 0.1 dB and for single mode better than 0.2. I say international standards, that's also a requirement in ANSI TIA now as well. The tester here actually sets a soft limit of 0.15 dB because we need to take into account the variability of these adapters in the field. This is not quite laboratory conditions here. So it passed, that means we got good test reference cords. So what that tells us now is when we start making measurements on our cabling system, if we start seeing failures, it's not because of poor test reference cords. It's because there's something wrong with that cabling system. Now previously I mentioned the use of a mandrel here. If you were not to use these test reference cords, I cannot guarantee that you're going to get better than 0.15 dB for multi-mode and better than 0.25 dB for single mode. Even if you use a mandrel, you're still not going to be in silk or flux compliant. There's no guarantee. So the only way that you're going to hit these numbers is using reference grade connectors. So if you're not using reference grade connectors, you're just not going to hit these numbers. So with that said, Amanda, let's go and tap next. And it's telling us to disconnect them. So we'll go ahead and disconnect them. Placing the caps back on there. It does make me chuckle when I see folks doing this in the field. Once they've done this, they grab the remote tester and they start walking off and there's no cap on the end face there. So clearly by the time they get to the other end, that end face has a whole bunch of dust on there. That gets transferred to the connector that you're testing and then everything goes downhill from that point. Thank you kindly. So we're pretty much good to go. Go ahead and tap next on the screen there for me. And then it's simply telling me to connect it to the link. And we're going to do that in the next video.